Okay, we're going to go deeper into use cases and examples, so that might be more fun. So community information, I told you it's like this little oracles are like little crystal balls that tells you the future. So when I talk about community information, we're looking at automated mechanism, and we're looking at the use of oracles. So we want to aggregate a flow of information, data, off-chain to on-chain, on-chain to off-chain, or within on-chain in the token ecosystem. And we're going to be sharing, there are 5 different types of oracles that we're going to talk about, as well as the different case studies or use cases that use this kind of oracles. The first one is software oracles. So it aggregates information available online, but it does not have to be on-chain, on-chain. It can be, because I say that information is data, the structure of data is more similar when everything is online, right? Because it can be a code where things can be read versus a piece of paper and pen where it really depends on handwriting. So software oracles help to aggregate information online, and you can just check, you can verify or get information with the same data structure. So it looks something like this. You have there are 2 examples. The one is Ether-ISK, which is decentralized insurance, and you have TSL Notary. The decentralized insurance thing, it's been in place for a while now, and they have applied it in flight insurance. So instead of, what do I mean by aggregating information? So if my flight is delayed, and I'm taking Ryanair from London to Berlin, and my flight is delayed, and it's so annoying, right? Now, flight is delayed. I have to go to Ryanair and tell them, oh, can you give me a piece of paper to prove that it's been delayed, and can you show that you've done everything it's possible and it's still delayed, and what's the duration of delay? Tell me when the next plane is coming. Give me all that information. It can be hard copy or soft copy. I take the information, go to my insurance, and tell them that, hey guys, my flight has been delayed, and I've got insurance. Insurance covers this, and can you compensate me? So this is the old traditional way where you have to be the one coordinating between all the activity of all the different participants, and it's very annoying. It's time wasting. If you can automate this, so much easier. How do we automate this? Firstly, instead of the insurance guy telling you, okay, give me this information, give me what Ryanair said, give me when it's delayed, give me how long it's delayed, give me when your next flight is. The smart contract will get information because they are connected, maybe via API, to Ryanair's Air system, or to the different airports that states flight is being delayed, new flight is this time, and then the smart contract has all the information from Oracle. They also have my information because it's my contract, right? It's my contract with the insurance people. And so when this happens, when a flight is being delayed, information is fed directly via the internet, via off-chain, via the airport or the airline's website or whatever, goes to the smart contract. Smart contract will validate the information is true. Maybe they validate the airline's website against the airport's website, validate that it's true. The smart contract will execute compensation and goes to my bank account. So my flight is being delayed. I don't have to do anything. The smart contract gets data from software oracles, and then I wait for my new flight. I take off, I land. By the time I land, I've got the compensation in my bank account. So that could be something. That's kind of how Ether-ISK works. The other one is TSL Notary. It's a base layer cryptography proof. So what it looks for, it's looking at, we look at proof, right? We want to validate. It's part of validation. And how do you validate a lot of different things? So for example, the internet says that, okay, go back to the story of smart contract. The internet needs to prove that I am a real person when I sign a contract, when I sign a smart contract, or when I created the smart contract. And it needs to validate my identity. Now, I could probably send them a picture of me holding my passport or holding it upside down to prove that it's me and my passport, and send them kind of some information that proves that it's me. Or it uses TLS notary proof. What it uses, think of it as you are in a maze, and then you don't know what the direction is to get through the maze, but TSL notary shows you the outcome. So in the same vein, TSL notary will search through the web and get a proof that you are who you say you are. This is your name, this is your birth date, and I can do that because I access your Facebook, I access your Instagram, I access your Twitter, I access the kind of medias you have online. And I can prove to the Oracle and say that, okay, when you sign this smart contract with Lisa, this is who she is. This is because I already made proofs to that. They don't need to know the exact, what you post on Facebook, what are the pictures posted. They just pick at the end of the maze, which is just your name and date of birth, to verify that you are a person. So we don't need a human to go and do all of that. We have oracles and software to do that. So that's software oracles. The other thing is hardware oracles. So software oracles is where you get information online. Hardware oracles, you get information offline via a client. So you know how we have a lot of IoT devices? You know how like IoT, Internet of Things, is everywhere. Everyone's talking about Internet of Things. Or we can use RFID, which is something that has been in place for a long time. And these are hardware clients. And they're basically the buffer between the real world and the internet world where data can be read. So, for example, if we go supermarket, we go to Tesco, we buy stuff, or we buy things, and sometimes they have this like scanner, and you can scan the kind of items that you buy, and it starts to collate what are the total amount of the things that you buy, as well as the prices of the total price that is in your trolley, your basket. So that it's something like that where it translates information on offline to online. It can be a cloud, it can be blockchain, doesn't matter, but it translates information. So in terms of Internet of Things, imagine we have Nest, Google's Nest, where you can control temperatures of a room. So temperature is a offline thing, and Nest controls the temperature, and that's now information. The information now is online, and then it's connected to other like Internet of Things devices, and the information is then built part of the Oracle, and then information can be fed into your smart contract or into on-chain whenever necessary. So two case studies, one is VeChain and one is Weave. VeChain looks at it takes actually both of them, it's quite similar, but they take information via all these like clients, IoT clients or RFID sensor clients, and then they put the information on chain, and you will use the on-chain system uses the information. So it's hardware oracles. Next, it's inbound oracles. So inbound oracles is where it's more specific to smart contracts, and it provides smart contracts with the data from the external world. So let's say we're in decentralized finance again, right? So let's say I tell the smart contract, okay, I don't need a broker. You will be my broker, smart contract. When ETH reaches a specific amount of money, I want you to sell it. When ETH reaches a specific amount of another amount, I want you to buy more ETH, and I want you to buy like X amount. And so the smart contract will execute this trade when ETH is that price. But how does the smart contract know what price it is? This is where inbound oracles come in, and they will go out to the different exchanges and gather information, and then it will be executed when the price matches the smart contract. So case study will be Oracleize. So with Oracleize, you send a question to the Oracle smart contract. You tell them you ask them that you need information from the external world, from the physical world, from the off-chain world. And then the smart contract will go and make and execute that process. It will execute it via an oracle, and then it will start going out and getting information using, it can be APIs or hardware clients or whatever. And then it receives the data to answer your question, and it gives you the information via the smart contract. So it's a very simple way where you have a smart contract, and then you use Oracleize to get the answer for the questions that you want, and then you get the answer, and then you can execute it on your smart contract. So that's inbound oracles. If you have inbound oracles, you have outbound oracles. Inbound oracles is getting information and data from the external world and goes into your on-chain, your smart contract. Outbound oracle is where you have information in your smart contract or in the on-chain world, and then you send the data out to the external world. So payments can, for example, payments made can activate specific things in the external world. So you have this thing called Airbnb that is in Zug, Switzerland. Basically, it works with a QR code, and you can make payment on blockchain. So you scan, you get payment on blockchain, it's being done, and then the activations, the activate services in external world part is where the bicycle unlocks, and then you can ride your bicycle around Zug. Thing is, so you can also use this without oracles, without blockchain, but this is just an example of a blockchain use case. And there are also other stuff like there are also other use cases, and oracles can exist without blockchain. Just a quick note. But when we're talking about on-chain, like blockchain-related oracles, then this number 5 will be a bit more relevant. It's consensus-based oracles. It doesn't need to use blockchain, but there's a relevance to blockchain, because on blockchain we are looking at getting consensus, and not just getting consensus on votes, on decision making, but also on oracles. So basically, individuals will provide inputs to the oracle system to inform or update the oracle. So I said oracles can gather information in 2 ways, right? The first one is it has API. It goes into the system. API is like it's like a way you extra hands and you can go into the system and get stuff. It goes into Ryanair's system and check if the flight is delayed. The second one is a hardware client, and it can go to Nest and check what's the temperature of my room. If it's too high, and then I have to charge someone more money, maybe. And that's information. What about information where instead of the oracle going out and get information, the oracle is relying on many other smaller oracles or many other individuals feeding it information? So you can, and this is based on, there are a lot of ways to organize this. So you can use agent votes, basic math, or AI to get a consensus. That's the part of getting consensus. But let's look at the different case studies to understand what are the different types of consensus-based oracles. The first one is a blockchain nervous system in Dfinity. So BNS is it's like a big brain for Dfinity, and it's part of their governance model. It makes decisions. It's part of AI as well. So it uses AI. What AI does is it analyzes different decisions being made by different participants. So it's like an oracle, right? It gets information, and then using AI, it will decide what is the best decision moving forward, and then it will be making decisions moving forward as well. So that's Dfinity. If Ultimate Oracle in Gnosis, it's an oracle. That's a bit more straightforward, where you just get information. Augur is where you have, Augur is a betting platform, and if people will cast bets, and then it gets information either by participants giving it together with participants giving it information, as well as the real world, so they can verify against each other. Shelling Coin is a coin. It's basically humans, like people, giving inputs to the system. So people are the oracles, and how to define, because it's a bit more, there's no fixed answer. Shelling coin, it's used when there's no fixed answer to stuff, where you can't get a definitive answer. So that means you can't just go into the API of websites to gather information. You can also use hardware clients like RFID machines to get information, because there's no right or wrong. It's not binary. On the other hand, it's really subjective. How do we deal with subjective information? How do we get consensus on this kind of subjective stuff that oracles bring? So Shelling Coin solves that, because everyone gets to vote on, gives information to the oracle. What the oracle does is to look at majority. So majority is the 25th to 75th percentile, so the middle 50% of the people, and takes that the thing takes that as the right answer, and everyone else on the side loses the stake. So that's how consensus-based oracle works in Shelling Coin. And in Witnet is another, like, kind of, just imagine a big computer, and it's connected to lots of small computers. So these small computers will verify against each. These small computers will all get information together, and the big computer will verify against each other. So if you think about it, Shelling Coin is individuals feeding information, and then information is being verified, and the middle 50% is correct. Witnet is where you have a lot of systems and computer systems giving it information, and then it's being verified against each other. That's consensus-based oracles. That's for community information. We're talking a lot about oracles.